Today our topic is going to be looking at geometric sequences, and you can use the date of June 8th. Your note packet should have 4 pages, and you will want a calculator as we go through this packet. Earlier in the year, we talked about arithmetic sequences. What we're going to look at today is a geometric sequence. So what we're going to have is a list of numbers. We need to know what the first number is, and then we should be able to find each number that follows by multiplying by a constant term, which we use as r, and we call that the common ratio. So when you list the terms of a geometric sequence, we usually use subscript. So a sub 1 is our first term, a sub 2 is our second term, and so on until we get to a sub n. And that just means it's our last term, but we don't really know what number term that is. The nth term is a sub n. That's typically the term that you're looking for. But just so you know, the term that comes before it, if it's not numbered, would be a, and then in subscript n minus 1. So if you were looking for a sub 10, then n minus 1 would be a sub 9. So it looks like fancy terminology, but it just refers to the term that came before. This is the formula for a geometric sequence so that we can find the nth term. This formula is on the reference sheet for our Regents exam, and I know we're not taking the exam, but we may need it in the future. So each term here represents something of use. A sub n we just discussed, that's the term that you're finding. Sometimes we put in, say, a 10 for the n. We might be looking for the 10th term, so it'll be a sub 10. A sub 1 is always the first term of the sequence. Quite often they'll tell you what that term is, but sometimes you have to calculate that term before you can move on to the next step. N is the number of terms that we're using or hoping to find. And then R represents the common ratio. That's our multiplier. When you graph a geometric sequence, because we're using a pattern of multiplying, what you'll find is that those points end up becoming an exponential graph. So it will grow slow at first, and then it will grow very rapidly after some time. If the common ratio is not provided for you, we can calculate it using this formula. So again, R is our common ratio, and it could represent growth or decay. We're going to use a sub n. This can be any term in the sequence, and you divide it by the term that came just before it. Let's start with some simple examples. In example number 1, we have a sequence. We're starting with -1, -3, -9. What we want to do is look at that and see if we can figure out what are we multiplying by. Now this one's pretty simple. We can see that we're multiplying by +3. So to continue the sequence, the next term would be -9 times 3, which is -27. And then you build off of that, -27 times 3 would give you -81. In example 2, you can see that we have the first 3 terms. Some are positive, some are negative. This one's not as easy for me to look at and determine R. So what I'm going to do is actually calculate it. You can pick any term in the sequence. I actually picked the second term in, but you could also pick the third term. We can't use the first term because there's no term before it. So if you pick the second term, you're going to divide it by the first term, and that reduces to -1/3. So this is a decay problem. So we're going to multiply 81 times -1/3, and that will give us -27. And now we'll multiply -27 times -1/3, which is +9. And you'll get that alternating positive-negative effect. In example 3, you can see that it's a growth problem. But again, it's not as easy to figure out what R is, so I'm going to set up the formula. I'm going to take 160 and divide it by 64, and that reduces to a multiplier of 5 over 2. So it's being multiplied by 2.5. So 400 times 2.5 is 1,000, and then building 1,000 times 2.5 is 2,500. For the next set of examples, we need to find the first 5 terms of the sequence. Because they provided a sub 1 and the multiplier r, we can go ahead and just start listing them. So it would be negative 27 and then times 3, and then that answer times 3. So I'm just going to bring up the 5 results, but I started with the first time, times 3, and so on until you get 5 terms, which is what they asked for. Same thing in example 5. We're going to start with 216. Our common ratio is actually a decay model. We're going to multiply by negative 1/3. So our next term will be negative, but then I'll take that result and multiply by negative 1/3 to get a positive. So these are my results. It is common for you to have a sequence of integers and then all of a sudden end up with a fraction, and then it'll be fractions from that point forward. So don't think that you did anything wrong. This is quite normal. For this set of examples, we're going to find a particular term that's described in the problem. So they're giving us a sub 1. Our first term is 1/3. The common ratio is 3. We're multiplying by 3. And they want us to find n equals 8. That means they want us to find the 8th term of the sequence. Yes, you could use a brute force method and multiply them out, but we do have a formula that was seen on an earlier slide. So we can do a simple calculation to find the 8th term. So what I'm going to do in the next line is I'm going to call this first term a sub 8. We're subbing in 1/3 for our first term, a sub 1. The common ratio is 3, and then we want to use n minus 1 as our exponent, 8 minus 1. One step at a time, I'm going to simplify my exponent to the power of 7, and then I'm actually going to raise 3 to the 7th power. And now I'm finally going to multiply by 1/3. So the 8th term is 729. If you go ahead and start with a sub 1 and multiply by 3 until you get there, we call that brute force. For number 7, we're going to find the 9th term. So I'm going to start with the formula. We're going to sub in the pieces that we know. So I'm looking for a sub 9, which is the 9th term. A sub 1 is quite large. My common ratio is actually a decay, and then it's 9 minus 1 for the power. All right, 3/7 raised to the 8th power. Make sure you put that entire fraction in parentheses, is fractional. And then I'm going to go ahead and multiply it for my final answer, which is also fractional. You can leave it in simplest form. Don't try to make it a decimal. Now, our next set of examples is trying to find a term, but I don't know what a sub 1 is. These problems have 2 steps. They want us to find the 10th term. I don't know what a sub 1 is, but I do know the 4th term is equal to 108, and it's got a common ratio of 3. So what we're going to do is we're going to deal with the 4th term so we can find the 1st term. Here's my formula. I'm going to leave a sub 1 as a variable. A sub n is going to represent the 4th term, but the value of it is known. It's 108. The common ratio is 3, and since I know 108 is the 4th term, I'm going to use 4 minus 1. All right, so I'm going to simplify. 3 to the 3rd is going to be 27. And now to get a sub 1 alone, I'm going to divide both sides by 27. And this gives me a sub 1 is 4. Now that I know the 1st term, now I can find the 10th term using the same formula. So let me start with that formula again. You'll notice now I'm finding a sub 10. A sub 1 is 4. I still have a growth rate of 3. And now I'm changing the value of n to 10. So I'm going to simplify. 3 to the 9th is rather large, and then multiplying by 4. So the 10th term is 78,732. We're going to do the same thing with example 9. They're looking for the 20th term, but they're providing me with a sub 7. So I know the 7th term, and I know the common ratio is 2. So just like in the last example, let's start with our formula. We're going to take the value of a sub 7, which is 2, and plug it in for a sub n. A sub 1 is unknown, growth rate is 2, and then the power of 7 minus 1. As I solve this, 2 to the 6th power is 64. We're dividing both sides by 64, and my first term is fractional, 1 over 32. But now that I know this, I can find the 20th term. So again, there's my formula. Now we're looking for a sub 20. There's my first term. I have the same growth rate of 2, and then my power is now 19. 2 to the 19th is quite large, and then times 1/32 gives me the 20th term. The last thing we're going to talk about today is writing an explicit formula. So what we're going to do is take some of the information that we have and write an equation to solve for the nth term. If we had 3 pieces, we would just solve it, but typically we don't have 3 pieces to sub in. So in example 10, I do know that the first term is -1, and then this one's pretty simple, so I can see that I'm multiplying by 5, so R is 5. What I'm going to do is start with this formula. A sub n is what I'm trying to find. That's going to remain the same. We're going to replace a sub 1 and our common ratio. And this is as far as I can go because I don't know how many terms I'm looking for, but this explicit formula will work for this current sequence. So maybe now I ask you to find the 100th term. So now you could sub in 100 for n and go from there. We're going to do the same in example 11. We're provided a sub 1, and we also can see that I'm multiplying by 2. So take my formula. We're going to sub in a sub 1 and our common ratio of 2. And again, that's as far as I can go, but this formula will work for this sequence. Maybe now you find the 500th term. This is homework number 127. You're only going to complete the problems that are circled here. If you have any questions, make sure you contact me, and I'm happy to guide you. Have a great day.